So now for example number 5, if I have the function, the absolute value of x over x, and I wanted to evaluate that, and I wanted to evaluate that from -1 to 2, let's graph it first. Now the reason Mr. Adams is purposefully graphing this is because you're going to find something very interesting about this function. If I do the absolute value of x divided by x and I graph it, okay, you're going to find something really weird here. It wants me to graph from -1 to 2. So if I plug this in my calculator, I'm going to get this little thing here, and this little thing here, and this little thing here. Now, the dimensions of those boxes is 1 by 1. So the area under the curve for each one of those boxes is 1, 1, and 1. So if you add them all up, my area under the curve could mean, it should be 3, right? If we're just talking about the area under the curve. But watch what happens when I do this. If I set my lower limit at -1 and my upper limit at 2, my area under the curve is only 1. Why?
Because it's 2 in the positive direction, 1 in the negative.
Yeah. Yeah, because the height, mathematically, the y value here is negative. So this is like -1, and then this is like +1 for that one, and then this one is like +1. So whenever we find the area under the curve, if the area is below the x-axis, mathematically, when your calculator graphs it, and if you do it by hand, it's negative. So the reason that we graph the function first is to see which portions of the graph is above or below the x-axis. Okay? So this is one of those things where we got to do a test. It's not a simple thing. You can't just plug it in the calculator. You really got to know what you're doing. So on those of you taking the AP exam, I guarantee you they will have you integrate a question. They'll give you a function. And the function will, from A to B, parts of it will be below the x-axis and parts of it will be above the x-axis. And then there's some applications to that. Sometimes the answer is 1, based on what the question is asking you. But sometimes the answer is 3, right? If we calculate the actual area under this curve, it's actually 3, right? So that's going to be, that'll be the challenge for you guys, I suppose. So anyway, how do we determine that? What is the actual answer? Well, technically the actual answer is 1, but like I said, depending on the application, it may be 3, okay? So for right now, they just want you to practice using your calculator. So if I were to plug this into my calculator, using the function integral, so in other words, if I hit second catalog, hit the cosine button to get me to the f's and go 1, 2, 3, 4, 5.
Mr. Adams, it's in math.
Is it in math?
Yeah, it's number 9 in math.
Okay. It's always in a different location, so depending on which calculator you have. Mr. Adams had a Voyage 200, which is like an engineering calculator, and I had all the menus. But it doesn't matter how you get there. I'll show you. I'll pull that up in a second, and we'll put it in the YouTube video. But anyways, our function for that particular situation was the absolute value of x divided by x, right? We're going to integrate with regards to the variable x. Our lower limit was -1, and our upper limit was 2. We saw 3 rectangular boxes, or actually squares.
It just goes really slow.
Yeah. But one of them was negative and 2 of them was positive. This decimal stuff here at the end, that's because we're approximating. That's because it's using trapezoidal rule. So we didn't talk about that yet, but we will. Remember we did the rectangular approximation method? One way to get around the error or increase your precision is that you would do a trapezoid, and so your calculator actually uses the trapezoidal rule, which is a little more precise. But the answer is actually 1, right? Okay, any questions?
No.
Okay.